And our final presenter closing us out is Ted talking about the research needs for manufacturing cybersecurity.
Thanks, Carter. So I am I'm the associate director under Julie and ZQ, and I'm also the faculty director of Vimmel's under Vimmel, basically, in his group at CDME. And so I thought I would talk about sort of how people who are here and stuck to the very end, if you want to be part of trying to help manufacturing, what you could do, what the needs are, and some of the things that Vimmel just talked about, but also some other things too. So ZQ and I just met with a really important person named Trent at Honda, and he didn't say drop dead exactly, but he sort of didn't say that he really thought that we could help, right? Is that the vibe you kind of got? That's the first offer. That's the first offer. I've done 30 projects, maybe at Honda, something like that. I've worked at Honda. You could work at Honda. People here, if you're a faculty and you want to spend the summer at Honda, I might be able to make that dream come true. And it's a good dream. It's a good experience. And I think they, including in IT and maybe some of the staff too, they do want talent. And I mean, I can't speak for them, but I think we could help that. But manufacturing, by some measures, is the #1 most attacked sector. I'm not sure exactly how that's measured. So what I want to talk today about, partly because everybody's sticking here, I know almost everybody, about just sort of the role of really high readiness level work and other things that we're doing and how to balance those and how to value both sides. And then I'm going to talk about sort of the drawbacks and benefits of this balancing process, because, even people like Vimmel, who are obviously doing really important things and great stuff, I still want them to also value the other side and people vice versa too. And I'll talk about some projects I'll go through this kind of quickly because these aren't really about cybersecurity, but this sort of tells you about me if you're curious, and also about how this balance can work. And then we'll talk about what I know about manufacturing needs briefly, and then some of the sort of not necessarily ready for prime time stuff, like the stuff that Vimmel just showed. It's ready-ish. It's moving up the readiness TRL levels. And then just a quick discussion. Okay, so, what is a university? What are we doing? And how is it different than being a consulting company? And, if we're trying to just do things that a company would pay for in a contract, and we saw this today, and I love seeing that today. I see that this group has talent that is at readiness level 9 almost. So that's great to see that we can do that. But it is true that, we kind of do stuff that's not quite ready for prime time. And that's great. We need to do that. And it's what a company would not pay for, but might get published or maybe even get a government grant. This phrase, hobby research, was used derogatively by one of our department chairs who really hurt somebody's feelings. I'm sorry about that, but it wasn't my fault. But I do think that I've started to kind of own this idea. And that person was talking about totally unfunded research, not federally funded research. But I think you could just sort of say that federally funded research, to some extent, is a little hobby research because it's not quite ready. And if you just only do TRL 9 or 8 research, then you probably don't belong at a university unless you really have great technical sauce. But the thing that we haven't really talked about in general, but I think all of us should really talk about more, is if you only do hobby research, you might not be on target. And, there's a big mystery of how we've really failed in recent years compared to old years in value per dollar research. That some people are saying 40 times. If you gave a researcher $100,000 in US dollars now, not inflation, in 1950, they could produce 40 times as many patents and productivity enhancements as now. There's a real mystery of why we're so pathetic now. And I'm owning this myself too. And I think partly because if we just go, a lot of our research may be off target. So in cyber, I also worry that I know I've been a little spoiled sometimes getting a lot of grants from that might not be that great. So so I think we're all kind of nowadays shooting for a balanced portfolio. And maybe in this kind of scary time that we're at in terms of research in the federal government, we might even be more going to higher readiness levels than we used to, in thinking, my gosh, we better start swimming with the consulting companies. But so the drawback of this is that you have to kind of run your consulting-ish type stuff at a profit, so you have some time for the other one, for the low readiness level work. And companies, a lot of times, they pay little, they demand schedules, train wrecks are possible. Vimal and I can tell you a horror story or two about some problems that we've had working with companies that, they were doing fraudulent kinds of things and lots of bad stuff. But the benefit is maybe at best, if we are being really, really practical, we could overcome some academic groupthink and pick particularly good topics, maybe drive civilization a little bit forward. And then, and the companies at their best. So like when we're meeting with Corsia, there's a lot of intelligence and will coming up from their side and helping to lead us. That's great. And there's other companies like that we work with. So getting mature offerings ready in cybersecurity is a real challenge. There's incumbent players like Dragos or Rapid7, and they're hard to swim with, maybe. Getting people to pay is difficult, given that standing out is a problem. There's a real herd mentality in cyber because you don't necessarily want to be known as super innovative in cyber because they're sort of like, over here, come and prove that I'm not super innovative. So that cyber might be a little bit worse than some areas for trying to get to the high readiness levels, but that doesn't matter. We'll do it. So, what I was trying to get across here is, in our medium bad example, I've done a lot of projects at Honda, and one thing we did a while ago was we wanted to get software to generate schedules for stamping operations. And you have to do 4 parts at a time, and you have to schedule 20 hours. And there was an actual guy named Louis that I know who works there and gets up at 5 a.m. or 4 a.m. every day and makes the schedules. And Louis didn't really want to be replaced. His managers wanted him to be replaced, but Louis didn't want to be replaced. And so that was a challenge. And so we made a special algorithm, and it could do things in Excel. But then we went there, and they didn't have the recent version of Excel, and Louis didn't want to. And so it was a kind of failure. But during it, we got published some articles in Good Students and helped graduated. We got into a pretty good journal here and Expert Systems with Applications. And so that shows that, we can sort of fail. And, I still have done 29 other projects with Honda. So it wasn't like they totally burned my connection, but it was a failure. And I love Louis. It wasn't Louis being a bad. Louis's resistance actually makes a lot of sense. Then, moving up, we just finished a project with NetJets, which is a company that works out of the airport, and they help rich people fly around, important people. And so we had to speed up and improve their scheduling for pilots. So it's similar. We were trying to come up with like, okay, what days are the pilots going to work on? And we did. We sped it up by 47 times, and we convinced them to use Garobi, not IBM, Cplex, and not their own thing, but OSC. And we tuned up their thing a little bit, and it worked. And so, hooray. And then, create a novel decomposition. Anyway, we did some fancy stuff. We are ready to maybe publish some stuff. That's pretty good. Our advanced, but, actually some of our fancy stuff didn't really work. That actually, at the end, we wound up recommending our enemy, a commercial vendor. So that was sort of a medium good one. So that happens, but it still worked. And so then, but then my greatest, or one of my greatest, because I have a few big greatest hits. This may be the greatest. Working with DHL Supply Chain, they wanted to speed up and possibly improve their bidding and planning software. So DHL Supply Chain has a North American headquarters right up in Westerville. And they basically bid to run other people's supply chains. They are the world's largest third-party runner of other people's supply chains. So they have this process where they have to bid for that. And they had some software that they'd made, and we wanted to improve that software. And boy, did we improve that software. And so we introduced a lot of cool stuff. And they documented $205 million in savings for their customers. But the real thing was the thing that they wouldn't tell us about, which was this huge increase in their win rate. So they totally owe us maybe billions of dollars. I don't know it. Anyway, so and we solved, the biggest large scale optimal routing problems in the world, probably. And I'm in the Edelman Academy, and we should have won the whole damn thing because they wouldn't tell us this number, fortunately. But anyway, the point is that's about as good as it gets. So that's technology readiness level 9. We not only invented a new type of way of doing optimization, we implemented and measured the benefit of it. That's as good as it gets. And I'd like to do that in cybersecurity. I mean, I'm ready. So let's do it. And so then when we study manufacturing, and I've worked at Honda for 2 summers, and I love those guys. They're sweet guys. And I, know a lot about all these processes they go through. And I'm not going to go through the detail of all that, but they need conservative, low maintenance 5G. They have, I shouldn't speak too much about them because there's some confidential things, but I think they would say that their relationship between the engineering talent and their IT talent is not necessarily what they wish it would be. And their 5G ability is not necessarily what they wish it would be. And if they put in some fancy thing, it'd be hard to get the talent to maintain it. The attack vectors include workarounds. So their stance, and this is probably true of a lot of manufacturers, is we're going to let all our engineers work in a pretty restricted environment, even more restricted than OSU by margin, kind of like the OSU MC. And then people are going to work around that. So that workarounds and how to manage that and how to discourage certain kinds of workarounds is a really important subject. Energy is also important, so that the technology we saw in the morning, they run their own power plant, and if they could run it better, they would. So if you're interested in that. Cloud environments, they haven't been using so much, but they could, and they might do things I don't know about. Compliance, they don't necessarily need it, but maybe something like it. And then, they do a lot of their own internal software. In fact, some of that we did. All right, so that's basically, now talking about what the kinds of stuff that my group and Vimmel's group together have done. We have our own vision system that we made for these guys, and we're ready to start measuring these gaps and flushes and create a database. And then we would create the data that needs to be protected for smart manufacturing. And so we have run static analysis on our own software and found a bunch of vulnerabilities. So then also our vulnerability maintenance software, where we try and model it, has a bunch of properties that we're really proud of. Like what Mohammed was showing about is that he didn't show, but we can also predict really well what vulnerabilities are missing in your scan data. We can also predict what your supercriticals are going to be, like what will be on the list. What Mohammed was talking about today was what will be on the list of the CISA list with known exploits next month. So we can actually predict that pretty well, although we miss some. And then AIDS and economic modeling, we can do that. anyway, so we're trying to get this software pretty ready and hopefully get people to use it. And because it can really cut costs. I mean, if you, a lot of the vulnerabilities that you really need to patch aren't in your scan data, and the ones that you really, really need to patch are not known to you. So, but we can help with that. And then we are also helping with cloud configuration design and trying to offer tunable ways to do that. We also are doing the playbook generator that Vimal talked about. I don't know if I should show this to you, but there's a bunch of decision problems in this, and we can do some math around that, and we can also do practical stuff around that. And then, Corsa stuff. And then I thought that was really helpful about the crumbs and then creating models to predict. So my last point, I'm almost done. When we met with the Honda person, the first meeting was not super, but that's okay. I've done a lot of these things. That's I wouldn't say that's normal. They're understandably skeptical because they know that we teach students and we're not a super crack consulting company. But we can get back, and I'm not giving up, and help is welcome, particularly if you have high readiness level things. I could try to help you get connected. I don't have to be the PI or anything. So then consulting, obviously we need both, but we need to understand that some people are going to think some of the things we're doing are kind of like a hobby. And we also need to understand people are going to think that some of the things we're doing are probably too consulting-ish. That's okay. So, I went through some examples and tried to point out that tool use is often an easy way to get to a high readiness level. So maybe we can't beat Drago, but we can help configure it and understand it. That's some Dragos or something like that. And we can model decision problems around that. Then I talked about the needs. We might even be protecting our own data because smart manufacturing is not really fully here. I mean, the companies aren't super smart and maybe they shouldn't be. I mean, if it was fully here, then there'd be a huge cyber problem probably because they're not ready to handle all the cyber attacks they would get. So the fact that they aren't that great at handling data now might be helping in some ways. But if we make them better, then we'll need to protect it. All right. So then the last thing I just wanted to say was that, what do we have that you want? If you have things that are mature and you want me to help connect those to people for sort of I would value if there was some scholarly aspect in addition to some consulting high readiness level, both. And I would be happy to try and help that thing happen with the people I know. Thank you.
Then if there aren't any questions, I think we're at the end of our agenda. So